with emphasis on fisheries and aquatic ecology, as well as fluid dynamics. I have been part of several research studies, notably studying the aftermath of the Exxon Valdez oil spill in Prince William Sound, Alaska. I have been involved in numerous fisheries research, including studying the effects of acid rain heavy metal toxicity effects on trout fingerlings. I have participated in population dynamic studies of Pacific salmon returning to Alaskan waters. I've also been part of climate change research. I was part of a team studying sea ice dynamics in the Arctic Ocean. I am also an educator. I have many years' experience teaching science and mathematics.
Good evening, everyone. We made it. We made it. It is Sandy Shellis and Jim Massa, and let us all cross our fingers and hope that, let's just hope that the computer stays on. I've had technical issues. Hi, Jim. We didn't even get much time to talk. Hi.
I
Hi. Let me pull up the chat and say
I,
hi to everybody. Yeah, the gang's all here. Everybody's starting to join. That's cool. Did you like that little video? Did you watch it? Jim. Earth
it's
to
a little
Jim.
embarrassing to watch myself.
Why? It was nice. I thought it was
It
cute.
was, it
Well,
was weird. Just
okay. Well, whatever. Take the compliment. Hi T-Bone, hi Cindy, hi Kay, hi Old Sage Joe and Kim Armad and Karen Reese, Anthony Davis, Gary Ballard. Hi Jim, great show today as always. Jim McHenry. Oh my God, he's a walking encyclopedia. And Jeffrey Pearson, hello. Jerome, hello Jerome. Calm down, Jerome. Take some deep breaths. And all right, well, let's get started. We have a good show. Hi, Tanya, Jack. Yes, all right. Uh, let's take some deep breaths. I need them. Oh, Jim, what's that noise? I have a little feedback. Okay, guys, did you hear that? Jim, do you have feedback? All right, I moved it. The feedback's over, I hope. See, it's going to be that kind of night, guys. Can you guys hear that? Jim, you got it's going to be one of those nights. Hi, Dee Dee. Well, as you join us, and I'm tired. I didn't do my Wednesday show. I had a MRI. I'll go next Thursday to see a doctor, but I know what I'm doing. I'm ruining my spine exponentially as the planet goes, so does Sandy's spine. Anyway, listen, I want to show you a shirt that I have on. It is the Arctic. It is the Arctic in full bosom method, full bosom mode. That was a gift from Katie, who's not with us. She's working. And she sent this t shirt, but I would really like to get another one for Jennifer. And she's lovely. And she sends t-shirts and things, and it's very sweet. So Jim, you actually could use one of these, the Arctic. It's nice, but I'm trying to be calm tonight because everything's just going wrong. And of course, this is not a venting show. All right, so we've got a show, and we've got some research, and we've got some articles, and I did not set up the screen share, so we might set it up while we're talking. Jim, why don't you give everybody a shout out? Hi, Rich Diana. He doesn't remember big mountains in the Arctic. Oh my God. It's Friday night. Anything goes, gentlemen and ladies. Is Jeffrey wants to know if my shirt's melting. Oh, great. Oh, okay. Happy Friday. Yes, let's give it an applause. Just getting here was not easy. All right, Jim, take it away while I play with the stuff that I didn't set up before. Uh-oh. Can't hear ya. Now we can't hear you. He'll fix it. Oh my gosh. Well, you're all out there. Yeah. Jim's excited to hear Jim McHenry's excited to hear Jim Massa. First we couldn't hear him. Then we got some. Oh, it's one of those nights. All right, Jim, talk. Talk.
Is that any better?
Yes.
Is that any
Just
better?
yes. Oh, that's
Okay.
better. Oh, that's much better. That's bassy and better. Yes. I just didn't get to fix anything. All right. Why don't you talk to everybody and say hi? A lot of people.
Well, thanks, folks, for joining us tonight. We have two major topics we're going to be discussing. First one is the declining levels of oxygen, dissolved oxygen in the oceans as the oceans warm up. And the second topic is water vapor. A lot of people forget that water vapor is a major greenhouse gas, and oftentimes it's water vapor working in conjunction with carbon dioxide, methane, etc., that will exacerbate what happens: the warming, uh, excess precipitation, etc. So those are the two topics that we'll be hitting tonight. We even slip in a little graphic that I just recently featured in my ocean heat content
And
update
I
video.
actually think I have it for later. Oh, it's
So
there. Yay. Okay. Hi, Jackie Cat.
maybe
That.
if we can pull up the on Peter Sinclair's uh,
Okay.
article,
All
we
right. I'm
can
going to try
uh,
to
go through and discuss that one.
all right. I will pull it up. I'm going to try to make us interesting here, like part of the show. Okay, Jim. We got it. Look at that. All right. Go for it.
Okay, so uh, as we see here, he basically says research ocean layers losing oxygen due to warming. Okay, they got a picture of a looks like a fishing vessel there.
Mhm.
And basically, he starts by saying by 2080, around 70% of the world's oceans could be suffocating from a lack of oxygen as a result of climate change, potentially impacting marine ecosystems worldwide. The new models find mid ocean depths, and that's important there, mid ocean depths that support many fisheries worldwide are already losing oxygen at unnatural rates and passed a critical threshold of oxygen loss in 2021. Now, oceans carry dissolved oxygen as a gas, and aquatic organisms need that oxygen to breathe. The oxygen is in solution. It basically diffuses across the gills, picked up by the bloodstream, and that's how organisms typically utilize dissolved oxygen. Well, it's a well-known established scientific principle that gas solubility decreases with an increase in water temperature. So this is perfectly, makes perfect sense from physics point of view that as we warm up the oceans, the oxygen levels, the dissolved oxygen levels, and other gases for that matter, their concentrations will decrease. And that's what we're measuring, and that's what, and it's the rate of decrease is at the point that it's starting to create issues for the ecosystem and is of now concern.
Mm.
So science has been trying for years, and it is what it is. So the new study uses climate models to predict how and when deoxygenation takes place, and it finds a significant, potentially irreversible deoxygenation of the ocean's middle depths that support much of the world's fish species began occurring in 2021, likely
Wow.
affecting fisheries worldwide. The new models predict that deoxygenation is expected to begin affecting all zones of the ocean by 2080. So the study was found in the is published in the AGU Geophysical
Yeah,
Research
I
Letters,
have it. It's not
and
this one. It's where is it? This one. Geophysical research letters. Right? You see it? That's it.
yep,
Just
yep,
yep.
that's
Gong and Zhao. Yeah. Yeah. I took
so
a look.
the ocean's middle depth, which is about from 200 to 1,000 meters, is referred to as the uh, mesopelagic zone. The upper layers is epipelagic. Then you get to
Mhm.
like, and pelagic simply means open water. So you're not
Okay.
necessarily over a shelf or anything like that.
All right.
And according to this study, the mesopelagic zone will be the first to lose significant amounts of oxygen from climate change. Now, the mesopelagic zone is where you find many of commercially important fish species.
Mhm.
So this will impact fisheries. You know how many the productivity, how many fish, the tonnage that you be able to land, harvest, etc. And not putting aside the fact that the oceans are warming and that the because of the stratification, thanks to the heating of the upper layers,
Right.
that productivity alone from phytoplankton is going to be decreasing, which will then means that there's less biomass created at the primary level. By the time you get to secondary and tertiary productivity, there's not going to be much left over uh, for the larger fish. So, if the phytoplankton's number declines, zooplankton's number decline, and then all the other species that feed on the zooplankton, et cetera, it all declines. So you're going to start seeing a major reduction in
Wow.
productivity across the board, impacting fisheries. And this is in addition to the already problem of overfishing, harvesting too
Right?
much. So now you throw in problems with productivity, deoxygenation, and you're going to be leading to a collapse of the fishery systems. Is really what's going to happen.
Wow.
So
I'm playing. It's not working. It's
so
going
this
to
is a major
collapse.
problem. Yeah, it could very well lead to that. Especially
So
as the oceans stratify.
I can't. I'm going to stop playing. I'm driving us crazy. My question about the other day, I think we had there was a discussion on Twitter. I don't know if I want to pull it up. And you were having a disagreement with one of the scientists. Do you remember what it was about? It was, I thought it was
It
something
was a
related to,
AMOC shutting down.
yeah, yeah,
Yeah, with that was that house
yeah.
father, whatever that guy his name
Yeah,
is.
yeah, he's a scientist. It's just it was
Yeah, I know who
I
he
thought it
is.
was related to this. I thought it was related to this.
It
I don't know if
can
you
be.
remember.
I mean, I,
Okay.
if you shut because if you shut down the vertical mixing, that will promote
Oh,
stratification.
I can't
So
shut that.
it is
Yes.
at least on the peripheral related to this because of productivity. But that disagreement was uh, he was like being dismissive that AMOC could shut down so soon, and I just had to say,
Yeah.
well, okay, you're obviously not an oceanographer. I am, but
Right.
I'm gonna give Wally Broker the final say on that one, and Wally Broker clearly indicated through his work that AMOC shutting down could be on the order of decades,
All
and
right.
and he Wally Broker literally did say like flipping a switch. I mean, so
Yeah, because I
so
know it's a
I'm going to
controversy,
go with Wally.
and yeah, I just wanted to ask you about that. I know it's a controversy, and as you were reading this, and we shall go on. We shall go on.
So let's see.
Tell me where we are.
So as let's see, what's the gentleman's name? Yuntao Zhao is an oceanographer at Shanghai Jiao Tong University. He's the lead author and lead, I guess, the PI. He said the
Yeah.
zone is very important because of commercial fish. Deoxygenation affects other marine resources as well, and but fisheries, of course, would be important for as humans are concerned. Um, Basically, this is just another issue with more problems with causing. Now, the researchers identified the beginning of the deoxygenation process in three ocean depth zones: shallow, middle, and deep, and by modeling when the loss of oxygen from the water exceeds natural fluctuations in oxygen levels. And the study predicted when the deoxygenation would occur in the global ocean basins. And
Okay.
they used the data from climate model simulations. And basically, the result of the simulation was that the mesopelagic zone lost oxygen at the fastest rate. And part of that is that if you start stratifying the
Yeah.
surface water, you're not going to get the mixings. You're not going to bring down the nutrients and oxygen to the middle levels.
Wow.
You're still going to see some mixing with the air water interface. So you're going to still mix in some oxygen, especially if you've got turbulent events and that
Mm-hmm.
sort of stuff. So you're going to at the surface mix in some oxygen. So it would be expected that they would lose oxygen last or at the slowest
Oh.
rate. But that oxygen still does not make its way down, from 200 meters to 1,000 meters. And when you think about it, the upper 100 to 200 meters pretty much the photic zone.
The
And so we're talking about being out of the photic zone. So fish in this region are going to rely on what we call marine snow, coming down, or they
yeah.
simply have to migrate up in the water columns, at certain periods of the day, only to migrate back down at other periods of the day. Well, in a process we call diel vertical migration. But so if you start stratifying the ocean, which the warming will do, this is the result.
Yes. The
And we
stratification.
find that this is very troubling because oxygen minimum zones are actually spreading to high latitude areas. This is troubling because high latitude areas have colder water temperatures. Colder water temperatures should hold more oxygen. And now we're
Mm.
seeing that it's also being affected. So, very, very concerning.
And concerning in what should we be like thinking about with these types of things that are happening now? What should we be thinking about for the future when these articles come out and they're talking about the ocean layers and what okay, what will we see with weather?
Okay, well, what we should be looking at is, with the oceans absorbing all this heat, 93% of greenhouse gas emissions
Yeah.
since 71. That heat is mainly concentrated, 68% of it in the upper 5 to 700 meters.
All
That's
right.
going to stratify the oceans. That's going to inhibit sequestration of carbon and heat to death. That's
Okay.
going to inhibit mixing of nutrients down to death, for productivity to take place. So when you start having that, you start affecting productivity, because of stratification.
Right.
Because for the phytoplankton to do their thing,
Yeah.
okay, yes, the water layers have to stratify, but they need
Yeah.
a mixing event to
Yeah.
get the stuff into the photic zone. And then you stratify the water level, which is temporary. They do their thing, their productivity takes place, yada, yada. Well, now if you have a permanent stratification, this almost permanent barrier to
Yeah.
getting to mixing in the nutrient, the productivity is going to drop dramatically. And that's the problem.
Oh
And
boy.
don't forget, phytoplankton provide 55 to 80% of
Yeah.
atmospheric oxygen.
They're like the
So,
super duper important things that nobody thinks about. I think I need a t-shirt
exactly.
that says I love phytoplankton. Yeah.
Yeah.
I think I'll do
So
that, guys.
if we get the stratification, we get, the phytoplankton start dying off, the whole
Not
ecosystem
good.
will
Well, they're doing
collapse.
it now. I mean,
And
we have
then,
terrible things. We have a comment from Gazer that thousands of dead crabs washed up around UK, and they are investigating. And it's the same thing. Even the manatees in Florida. It's the beaching whales. It's all of the critters. I mean, can you add to that? Is anything happening up in your neck of the woods?
well, what they, uh, we've had dead zones off like Oregon, the coast of
Yeah.
Oregon, and stuff like that. What they'll be
Oh,
measuring in the UK is they'll probably be
yeah.
measuring what's called biological oxygen demand.
Oh,
And probably the BOD would be, you know, basically suck dry the oxygen content, and then in essence, those organisms suffocated. So yeah, it's we're over. A couple of factors: too many people on the planet were overfishing to begin with, and then we create all these. We're changing the entire physics of the ecosystem,
the whole
changing the
thing.
parameters.
Wow.
It's no wonder the whole everything's going
So, do you
going to
think
shit in plain English.
did you watch me? You watched with Paul, and we talked about the Endurance 22. That's now I'm
Yeah.
following the scientist that, and I'm sharing his videos every day, and I'm really fascinated with what they're going to find besides the looking for the endurance. His what they're going to find in each the stratus of the ocean, temperatures, and the amounts of greenhouse gases trapped in there. What do you think?
Wait and see. I mean, can't really say much until we see the data. And they're probably
Yeah.
collecting the data anyway.
And
So,
what is the data going to be good for that they collect besides looking for the ship? Tell us what it's going to tell.
well, give you it'll give us current condition. I don't
Okay.
know if they have data from the past, because if you have data from the past in that specific region, then you can look for trends and that sort of stuff. Uh,
Okay.
but if they don't, then the data we collect now will be of use, and then in conjunction with data from everywhere else,
Yeah, I'm really
you can
interested.
construct profiles. You can
Yeah.
construct temperature, salinity, density profile. You can construct nutrient profiles. You can construct oxygen, CO2 profiles. So
And that'll
you
really
get a lot
tell
of
us what's
information.
happening. Yeah, it's going to tell us what's happening
It, it,
in
it'll
Antarctica
give
and
us it'll
the
give us an
polar
idea.
stern. And the polar stern data is starting to come out also. And that's really exciting.
Yeah.
I love the ocean, Jim. That's why I like listening to you and learning. I learn something new every day. It's not easy, it's not always easy. But I think that it's really valuable, and I like it. And somebody asked me on that show, did I like why don't I like space? I'm like, no, I'm so much more into the ocean than what they're doing in space. I don't know. I think it's going
Well,
to tell us more about
it
our planet.
the other thing is that you know everyone's concentrating on the atmosphere because we breathe gaseous oxygen, but we really come down to it's the oceans that the main driver of climate, and
Yeah.
we now have all this heat in the oceans. Think of a capacitor. What does a
Yeah.
capacitor do? A capacitor stores energy, and then
Yeah.
it does what? It discharges it,
Just charges, right.
right?
Right.
So we have all this heat energy in the ocean, and it's just waiting to be discharged. And you know what? It's happening. We measure heat fluxes, which is basically giving up the heat to the atmosphere. And when you start increasing, the heat flux to the atmosphere, you're increasing the warming. And don't forget, as you
I
increase the
want to
water
forget.
temperature,
Yeah.
the the ability of the oceans to absorb gases decreases. So it's not going to absorb the CO2 from the atmosphere into the ocean.
Right.
That's going to stop. The oceans continue to warm up. The gases that are in solution will start to outgas back to the atmosphere, including CO2, further increasing CO2 levels.
Can I ask you a question? My mind takes me to these crazy places. So, carbon sequestration is out there, to take it out of the atmosphere. What's going to be done in the geoengineering realm when they discover that, uh-oh, we have to do something to take all these gases out of the ocean, cool the ocean? You have any clue on anybody doing any research? Not that I like it, but just came into my head.
It's like anything else with geoengineering schemes. There are always unforeseen parameters, unforeseen interaction that
Right.
basically throw a huge wrench into the works. Uh, it's like, oh, we got to cool down the oceans. Okay, where are you going to put the heat?
We're gonna put
I
ice
mean,
cubes
look,
in.
I mean, think of an air conditioner, right?
Yeah.
When you run
Yeah.
an air conditioner, what does an air conditioner do? An air conditioner simply removes heat from wherever, the room, the space, whatever, and it does what?
Yeah.
It dumps it else. It dumps it elsewhere. In the case of like in a home, it dumps it outside the home.
I know.
So you got this heat in the ocean. Where are you going to put it? You got the heat in the atmosphere. Where are you going to put it? Oh, let's remove it. Where are you going to put it?
Are they gonna make
You
no,
you
I
can't you
these
can't you
scientists,
can't mess with
they're gonna
you
make it
can't mess
into
with
energy.
you can't mess with
Everybody.
thermodynamics. You can't mess with
Right.
thermodynamics. I mean,
So in your estimation, Jim, is there a way to slow it down? I mean, everybody's always talking, and I'm sure we've talked about this, but I'm going to ask you again. Our audience is pretty savvy. There's a way to slow this down. The
um,
heating would the burning, stopping burning fossil fuels, which I'd like to see. Is that going to do anything?
two, two words: thermal inertia.
Yeah, that's. I knew you were kind of. I mean, I've done enough shows with you.
I
Thermal
mean,
inertia.
there's so much thermal inertia in the oceans that we can go to zero emissions this very instant, and we're still screwed.
Okay,
To be
who
blunt,
wants a thermal
to be
inertia
blunt.
shirt? I've got a bunch of shirts tonight. We're gonna have the
Put
Environmental House thermal inertia shirt and have your face right on it.
I used to have a
Jeez.
T-shirt. Well, it's gotten too small on me. It showed a triple integral with all sorts of crazy, Dell operators and cross products and stuff like that. And it basically says, "What part of?" And it showed this equation. Don't you understand? And what it was a flux equation. But,
Okay. Flux equation. All right.
but
All right.
but but to kind of build on the article we just
Yeah.
discussed, let's go to the energy
Let's go.
mix one there.
Let's
Because
go.
it's the same thing, but they take it a little further.
I am moving on. Okay. The energy mix. Correct? Is this the one?
Let me see. Yep, the energy mix one.
Okay.
That one right
All right.
there.
I'll pull us
Oxygen,
up.
oceans warming, lose coral reefs
All right.
face new stress. So
Tim Radford.
it's going to be similar. In fact, yeah, he wrote the article. It's going to feature the same scientist Zhao from Shanghai. So there's going
Okay.
to be a lot of s- overlap,
Yep.
but as it
Well,
starts
this.
here, last 7 years, more than half of all ocean surfaces have been hotter than any time in human history. And since 2014, these heat extremes have happened on a regular basis. And then they talk a couple of studies looking at this, that the oceans are warming so much that oxygen levels are declining, threatening organisms basically with suffocation. And then a third study looked at the planet's coral reefs, and they're endangered by global
Yeah.
heating. We know about the coral bleaching effect, but this is another insult that they have to deal with.
Okay.
And
A new
you know,
insult.
so basically, you're heading to an extreme thermal stress on organisms. I mean, when you think about it, if you're a land-dwelling organism, if it gets too hot, you seek shade. If you get too cold, you seek the sun. You're in the
Yeah.
water. If you're in an aquatic organism, you're in the water. Where are you going to go? You're going to move to find, water temperatures to your liking. Sometimes that may take you to a spot. We go, okay, now where's my food?
Right.
Aquatic organisms have a more difficult time dealing with temperature
Ugh.
changes. They just do. So the issue that aquatic organisms have to deal with. So now, fortunately, we have 150 years of ocean data temperatures, and a lot of it has been measured directly. CTDs, drop a thermometer, that kind of stuff. Sometimes we've reconstructed the past from proxy evidence, looking at isotopes, and other methodologies. And basically, they use the Public Library of Science, or PLOS Climate. They use a century and a half of data to settle on average temperatures for the years 1870 to 1919, then a definition of heat extreme, and so on. So they're basically looking at establishing baselines on which to do present day comparisons. And the first 50 years of their study, they found ocean temperatures reached extremes as once in 50-year events over just 2% of the sea surfaces. Then they looked at
Wow.
the following century. By 2014, more than half the ocean had surpassed the level defined as extreme heat. And by 2019, that proportion up to an astonishing 57%.
Mm.
That is showing how
Wow,
warm
Jim.
the oceans have gotten. So, in other words, the Atlantic, Pacific, and Indian Oceans, the three major ones, have new average temperatures and past the point of no return.
Jeez.
To
It's
go
pretty
back to your point, oh,
scary.
cool down the oceans, whatever.
Right.
You have to remember,
Not gonna
the
happen.
specific heat content of water
No.
is so much higher than air. If I have a cubic meter of air and a
No.
cubic meter of water, if I want to heat up the air 1 degree C and heat up the water 1 degree C, it's going to take a shitload more energy to heat up the water 1 degree C. A real shitload more energy. So that's also very unrealistic to say, oh, well, it'll just cool down the ocean. Oh, well,
I know.
good luck with that.
I understand that. I understand that. I'm just playing the little devil's at
Can't hear
It's
you.
been
Okay, you're back.
it's been affecting us for a while. Our research shows for the last 7 years, more than half the ocean has experienced extreme heat, as mentioned above. So, Monterey study grew from research into changes in the kelp forests off the California coast. Kelp forests and seagrass meadows like coral reefs are vital for the health not just of oceans, but also as nurseries for the growth of commercial fish species and other species, really.
Yeah,
And
those spaces.
these ecosystems can and do collapse as temperatures go up. And then, of course, as we just discussed, the increased water temperature, dissolved gas levels drop. So they go on to say that they work from computer simulations of temperature change and gas levels, as we discussed earlier, in the mesopelagic zones between 200 and 1,000 meters.
Yeah.
And that's when they found, as we discussed earlier, that commercially important fish species are in danger, and that the deoxygenation could reach critical situation in less than 60 years, basically.
Less
And
than 60 years. Boy, isn't that a less than
and
60 years.
I mean, do you most, polar regions, high Arctic, high latitude are very productive. Mid latitude regions also quite productive. The regions that are least productive are the tropicals. Why? Because the waters are so warm, you almost have a permanent thermocline there, and you're just not going to get much productivity. And so the fact that this is affecting mid to high latitude regions is definitely of major concern.
Right. Mm.
So, um, so that's the essence of that particular article, and yeah, it's a very troubling trend. I know I've always mentioned gas solubility issues in some of the videos I've done because it is an issue. And if you're an organism like say a great a great white shark, a bluefin, a marlin, these are homeothermic organisms, and to that means they have a higher metabolic rate and therefore they need a higher oxygen level to run their metabolism. Well, if the oceans start warming up, these organisms are going to be extremely stressed out.
They're essential organisms, really. Everything's an essential organism. Everything
Everything's
we
essential.
lose, everything that goes extinct, they're all essential. They're all essential. I just keep thinking about how does this planet live with it's all paved over on the planet with just growing areas and buildings and concrete and lights. I don't know. And then a dead ocean. How does that work? It
It
doesn't.
doesn't. I did a video some months
It
ago where
doesn't.
that the biomass of well not that excuse me, the mass of all human structures, roads, buildings, etc.
Yeah.
Concrete, steel is now great on land.
Oh, I
Think
keep
about that.
losing my.
The
I
the
keep
the
losing
mass
my. Hang on. I'm listening. I keep losing shit because the computer's not
the
doing well.
the mass of everything we have constructed is greater than the terrestrial biomass.
Hmm.
That's just mind blowing.
Uh, Give me a second. Test my. Okay. I keep losing my. All of a sudden, my mic is gone. I don't know what's going on with my computer. I'm so mellow. I'm so sick of it.
I can hear you fine.
I know you can. It just keeps changing on my board. It's just like gone. This now it's coming through this. Okay. All right. So, what are you guys doing out there in the chat? It's somber news, Jim. You know, all the studying and all the stuff is great, but it's somber. It's somber.
I always bring depressing news, don't I?
It's not you. It's the nature of our show. I mean, what, okay, I don't even need to do that until I can fix that. Jennifer and I, we were for being, going back and forth and having banter and smiling, when we're presenting such horrible stuff. But what do you do? I mean, it's sad. It's overwhelming. Like my laptop is overwhelming. It's going. My technological, uh, link to the world. All right. So I'm getting questions, Jim, and I'm going to put them up. Hey, guys,
Okay.
yeah, you're doing it right. You're doing it right with the cues. Thank you. Thank you. Thank you. All right. Let's go to the first one. Tanya. Perhaps you covered this while I was partially listening. Been wondering, when does ocean decide it's absorbed all it can and start expelling the heat? She thinks she heard you say it, but maybe, you know what? If she needs it, maybe we all need a little bit. Go over that again. Thanks.
It's a function of temperature. Gas solubility decreases with an increase in temperature. So it's a matter of, you know, for a given temperature, what is the solubility equilibrium?
Hmm.
You know, when are they balanced? But as we keep warming the waters, the equilibrium level keeps decreasing. So at some point, you know, whatever, as you have a given concentration of gas, and it's at present at a given temperature. Well,
Right.
now you increase the temperature, you keep increasing the temperature, it can't hold all that gas, so some of that gas exits, and it exits by going into the atmosphere. Now, if you cool down the water, then the water can hold more gas, and then it can take in gas from the atmosphere, dissolve it in solution in the water. So it's another of the equilibrium point for given temperatures. So gas and gas solubility and temperatures finding that balance.
Wow. Hey, I have a question that's leading out to her. So the ocean decides I'm done because of the buildup, the gases, the mix of the gases, and then it's what? And this is what I'm leading to. Do you think that these eruptions, do you think tectonic plate problems, all those things that are happening underneath are affected by the gases?
I'm not really a geologist. I know there's some
We
people
need to
who
get one on.
posit that,
Yeah.
but you have to look at the depth of where these things are taking place. If it's below 2,000 meters, I'm gonna probably say not really,
Okay.
because
I don't know. I'm
um,
learning.
now there is some hypotheses that because we're melting all the major ice sheets,
Right.
that by taking the water and putting it into the ocean, we're increasing the pressure that is eventually felt at depth, and that could be inducing some tectonic activity, as well as changing the angular momentum of the planet itself. So that some studies are saying that the Earth's rotation is actually speeding up, which is a very interesting finding because Earth's actually rotation, since its formation, has always been slowing down. I mean, Earth used to have 10-hour days, now we don't. So it's always been slowing down, but now they're saying, oh, it's the angular momentum is changing, so it actually might be speeding up, and they're attributing that to basically redistribution of mass, and then if you're taking the mass in solid form on land, putting in liquid form in the ocean, you're basically changing the mass distribution. That changes the equal momentum, but now you have increased pressure at depth, and that could be affecting what goes on at tectonic boundaries. That's some of
Wow.
the hypotheses being tested.
Wow. Okay. Whew. Let's see what else we have here. Thank you. Here's one. Let's just get to the point. How in danger are the oceans of failing? Just get to the point.
The oceans are dying. The oceans are dying. I'll be blunt, they're dying.
And I have to say this. I Somebody was sending pictures there scuba diving in the Bahamas, and it absolutely looked gorgeous. And you look at these pictures, and they're there now, and they're sending them, and you think, how could this be? How could this be? But then you see the pictures of what happens in Florida, the starving manatees and the dead fish. And wasn't there just a huge dead fish? Well, that was from fishing. Like a lot of fish, 30 miles or something like that, were let out from commercial fishing. I don't know where it was. Oh,
Hmm.
Jim.
Well, the
Oh
thing
my
is,
God.
in tropical waters,
Hurts.
because the
Maybe I
productivity
could pull that up.
is so low. Yeah, the
Yeah,
waters are going to be nice and crystal clear because there's no productivity. It's
right.
what we call oligotrophic. So
Oligotrophic.
so yeah.
I learned all that when I took Great Lakes ecology. Okay, I want to see if I can find. I'm going to pull up that fish dump that where they, what's coming up? Fish dumplings. It was a fish dump. I don't know where it was, but it was horrible. Did you guys hear about that? Where the fishing trawler? the it was a lot of fish. Oh well, I guess I'm not gonna
Well, that's
look
the other
that up.
problem with trawling is that they're
It's
extremely
horrible.
indiscriminate, and they just literally just dredge up everything. And by the
Yeah,
way, if you got the bottom trawlers that
yeah.
basically scrape up the sediment, that's another source of adding CO2 to the atmosphere. Because when it dredges up
Holy
the
shit!
bottom,
You never
it
think
it
about that.
disturbs it disturbs
Oh
all the
my god.
sediments, the
That was
organic
it.
material, and
Yes,
that leads to increased CO2 in the atmosphere.
yes. Alan said it. The fish dumping off France. Sorry to get you out of that whole mode, Jim. Uh, thank you. It was horrible. Yeah, it was horrible. Oh my God. Well, we do have questions, and thank you for answering that. I know I'm really not I'm just like not on my game tonight. Let's see. Gosser says oceans will release unexpected amounts of heat just when you don't need it, hence destructive storms. Ah, okay, that was answering from a while back. Okay.
That's a very good point there because when you put up the heat in the atmosphere, right? What do we always hear about hurricanes? Feeding off the heat in the oceans. Well, yeah.
Uh-huh.
Now you've warmed up the ocean. There's more energy for the hurricanes to feed off of. So yeah, they're now talking
Wow.
about creating a category 6 for hurricanes now because of
Yes,
wind
oh
speeds.
yes, I read that. That's insane.
So that makes perfect
Category
sense.
six.
You're adding the heat and warmer air can hold more moisture. For every degree C of atmospheric warming, it can hold about 7% more moisture, which means the storms are going to be
Okay,
even wilder.
why do they have to make a category six? Why can't the scientists adjust the categories they have now and just lengthen the severity of each chunk? So category one, it goes up a little bit. So stay five and just know that category five is worse.
Because that's changing the methodology.
It is?
And
Really?
that's yes, because if the established standards are Cat 1 is from this
Oh,
speed to this speed,
yeah, for
and Cat 2
insurance
is from
too.
this speed. It's why I have a major problem with the IPCC. They keep moving the goalposts. It used to be 1750, now
Oh,
it's 1850, and now it's 1880s. And then they keep
what?
saying, but it's only warmed up 1.2. When you look at 1880s, but when you look at 1750, it's 1.6.
Well, it's
They
like
keep
cherry
changing.
picking.
They
Everything's
they
cherry
keep
picked.
moving chain method, which is poor science.
Yeah. Let's see. All right. Let's go for a couple more questions before this whole thing just wants to say goodnight. Take a crap. All right. Hello there, man with many names. Do you know if anyone has ever been injured in a Pingo explosion? Question for Jim.
I can't say one way or
Ping!
the other, but you probably don't want to be around one when it lets loose.
No. Nope. Okay, well, that was a fun question that we don't know the answer to. Here, what are the levels of the dead zones expanding at today?
Well, that's going to depend on which specific region you're looking at. What are the specific parameters? What's the bathymetry like? What's the currents like? And what are the physical aspects like? That's going to vary from spot to spot. There's no
Yeah,
one definitive answer for that.
okay. I'll pull up another one. See, I can't, I'm so distracted. Oh my God,
Yeah,
I'm terrible hostess.
it's going to be site specific, basically.
Site, so like the Antarctica will be different with the expansion of those zones. I mean, they're obviously going to expand, you know,
Yeah, we've for years it was the blob or the dead zone off the coast of Oregon. Uh,
the
that
blob.
then you've got other dead zones up and down various seaboards.
Oh, it's
So
working again.
it's going to be determined by what are what are the currents, what are the physical parameters are like,
All right.
etc.
So but it doesn't matter. No matter what, there's going to be dead zones in the ocean. Oh, here's a good one. And you know what? I don't know if I read this. Have you read Rich? Have you read Robert Hunziker's new article on ocean heating in the northern oceans?
I
Ooh.
have not.
Ooh, should we pull that one up? Ocean heating. Oh, Robert Hunziker's a good writer. Why don't you write more, Jim? You should write. You probably could write some kick-ass articles. Let's see if I can get it. I don't know. Um. All right.
I mean, I
Let's
just,
look at them.
I present stuff that, I look into peer review journals, and
Yeah.
yeah, it takes when a lot of the videos I've been doing lately have been examining peer review journals. It takes me it
Oh
takes
God.
me, because a lot of them are big articles. It takes me several days to really read it carefully and
Oh,
really
this came
go
out
through
today.
the
Yes.
data and stuff like that
Well,
before I
yeah.
start, talking about
Research
it.
research articles are not. I mean, I looked at this one, the geophysical letters. There would be a lot for me to go through that because I don't understand as much as other things. Look, here's the article, Jim. Ocean heat killing spree. Robert Hunziger. Can you see it?
Well, yeah,
Look at this
this might be a good
today.
time to pull up that graphic I sent you.
Okay, let's pull up the graphic. Why not? Let's go for the graphic. I have it right here. Okay. Why don't you tell us what the graphic
Okay,
is?
this was just featured in my ocean heat content update video,
Mm-hmm.
and that red arrow, I put that red arrow there,
All
and
right.
basically what you're seeing there is ocean heat content anomalies measured in zettajoules. That's 10 to the 21, and
Yes.
the baseline data is from 81 to 2010, basically a 30-year period. And if you look at 1995, where I put the arrow, before 1995, when compared to that 30-year baseline of 81 to 2010, the oceans were cooler. On the other side of 95, we see the oceans rapidly warming up. And I contend that is the tipping point for the planet, because the ocean's absorbing all this heat, waiting to discharge, and it is doing so. That this is what starts leading to the stratification of the oceans. This is what starts leading to the problems with productivity and fisheries we've discussed. But now you're putting that heat into the atmosphere, and it will do that. Then you warm up the air, you then increase the thaw rate of the permafrost, increase the methane, increase the
Mm-hmm.
CO2, and also, as we discussed earlier, warming up the ocean, some of that CO2 is going to outgas back, as well as the CO2 introduced from fossil fuel burning.
I see.
This is going to lead to rapid exponentiation, to the point where the exponentiation itself exponentiates. And so this is 1995. You can see that there's a lag effect involved. And I am pointing out that year as when we basically crossed the point of no return for the planet and us
Wow.
as a species.
Wow. That's pretty heavy duty, huh?
That's
All right.
extreme serious shit there.
Wow.
It's mind blowing. And when you look at the cooling anomalies, it's nowhere near the magnitude of the warming anomalies that we
Mm.
see, especially in the last, you know, 6 7 years or so. I mean, 2020 was a record setting year for heat absorption by the ocean, and 2021 shattered the 2020 record by 14 zettajoules. So the oceans are now storing on the order of some 240 zettajoules of heat energy. That's just crazy.
Why is Jack saying show us the current year, not 1995?
Well, just look at the little tip there in the arrow. That'll be 1995 level.
Right. Okay. It should. That's the divide. I mean, that's where you see the change, the
Yeah,
divide. Yep.
that's the flip over.
Yep. I
That's
see it. I see it. Oh shit. Wow. Heavy duty. So this is the article from Robert Hunziger. I suppose everybody should read it because we're not going to read it now. We would be here for a long time. It looks good though, Jim. Let's read it, and we'll come back and he does a lot of research. Let's go down. It's not really that long, actually. I don't know. What do you think? Let me see what the chat says. Should we read it? Guys, should we read it? Let's give them a second. Nothing's, I mean,
Sur-
my microphone is
Survey
back
says.
working. I know, survey says my microphone is back um, working. It's not that long of an article, though. And I think it looks cool. Oh, what the hell? Should we? It's Friday night. You want to do it, Jim? Should we do it? We'll tag team on it like me and Jen do.
Well, you can try. I don't know if I'll be able to read it.
Oh, all right.
Without
Well,
because when I was
all right.
reading the
We're
other
gonna
articles,
read it.
I had set it aside and I pulled it up on a
Okay. Well,
separate
I'll tell
tab.
you what. I'll
Yeah,
look
if
at
you
it.
want, you can take. Yeah,
All right.
you
You
can
stay with
take the
me
lead on
here.
it.
Stay with me here. I'm gonna put you back on and play with our little blobs of there we are. All right, let's do it. So this is Robert Hunziger. We all know and love Robert Hunziger and Counterpunch, and it's exactly what we're talking about tonight. Ocean heat killing spree. Maybe I'll make a video just out of this part. I'll make a clip. Like other channels do, they make clips from their long live streams. All right, here we go. Ocean heat killing spree. The oceans of the world are undergoing a dangerous and damaging upheaval that manifests throughout scientific studies of late. Whether it is the world's fisheries of the Bering Strait, or coral reefs of the Mediterranean Sea, or emaciated gray whales along the Pacific coastline, study after study describes sudden, sharp downturns in all categories of marine life. What's going on? Well, Jim, what do you think? Didn't we just spend this whole show saying what was going on?
Pretty much.
Yeah, pretty much. Pretty much. Don't feel like you can't interrupt me. If something like gets you excited and you want to say, hey, wait, let's do it that way. All right. Global warming is the culprit of this deeply disturbing, disheartening affair, and it begs the question of whether any nation, state, or unified nations can do anything about it. After all, save the whales and save the oceans have been rallying cries in grocery store parking lot signature gatherings indicative of the broad reach of public concern for decades now, but to no avail. In fact, over time, as the signatures piled up, it's only gotten worse and worse, and now scary. Deadly marine heat waves that repeat over and over again within short sequences carry a massive destructive punch. These events are new to the scene, starting in the 21st century when anthropogenic warp speed that impacts and alters the climate system inadvertently kicked into gear. According to a feature story in Nature, fevers are plaguing the oceans and climate changes, making them worse. That was dated May 5th, 2021. Sudden marine heat waves can devastate ecosystems, and scientists are scrambling to predict when it will strike. That same Nature article discussed when scientists first noticed the serious damaging levels of significant impact by marine heat waves. 10 years ago, dead fish began washing ashore on beaches of Western Australia. The culprit was a huge swath of unusually warm water that ravaged kelp forests and scores of commercially important marine creatures from abalone to scallops to lobster. Over the following weeks, some of Western Australia's most lucrative fisheries came close to being wiped out. To this day, some of them have not recovered. Recent studies have focused on the frequency of marine heat waves as the main culprit in this grisly affair. Interestingly enough, marine heat waves are happening coincident with ground heat waves. The planet is heating up like never before as ground temperatures hit all time records in the northern hemisphere as well as the southern hemisphere, and ocean temperatures threaten the world's major fisheries of the far north. According to the NOAA, July 21 was the hottest month in recorded history for the world. The European satellite system also confirmed that the past 7 years have been the hottest on record. Already for this year, the southern hemisphere of 2022 has witnessed several all time peak temperature records in January, especially in Argentina. Similarly, Australia has set new all time records in January. As the beat goes on, the world ocean in 2021 was the hottest ever recorded by humans, and the 2021 annual OHC value is even higher than last year's all time record value.
And this is during a La Nina year, by the way. 2021 was a strong La Nina and was
Uh
still setting
huh.
records.
It was still
And
setting
keep in
records.
mind that there is a lag period from land temperatures to ocean temperatures. For
Wow.
example, in the northern hemisphere, oceanic summer is in September. Oceanic winter is in March for the northern
Oh,
hemisphere, and it flips for the southern hemisphere. So that oceanic summer in the southern hemisphere is in March. Oceanic winter is in September. So it's
okay.
like a 3 month lag between air temperature and
All
water
right.
temperature.
I got you. I got you. All right. So where was I? All right. So he's saying it's indisputable that they're under attack. I don't think I read that. By excessive amounts of CO2 and way too much heat. Ocean absorbs 90% of the planet's heat because global warming, killing marine life outright at a record clip. For example, a billion sea creatures killed by ocean heat off British Columbia coast in the summer of 2021. The situation is even worse than that, as the world's major fisheries of the far north are threatened like never before, potentially the crisis of all crises. Oh my gosh, right? The essence of the issue is not simply ordinary old marine heat waves, similar to regular climate change, which is the common retort by climate deniers with bogus statements like, the climate always changes. And let me tell you, Jim, I fucking hate when people say that. I hate it. I do. That's why I don't call it climate change anymore. I call it climate disruption because then that's one less asshole I have to fight with. So, au contraire, garden variety climate change is not the issue here. Not at all. Not even close. The problem is the frequency or recurrence of consequential, deadly, severe heat waves, such that marine life does not have enough time for a comeback once it has been blasted. Only recently, a team of curious journalists from the LA Times traveled to the far north to meet marine scientists and reported forces profound and alarming are reshaping the upper reaches of the North Pacific and Arctic Oceans, breaking the food chain that supports billions of creatures and one of the world's most important fisheries.
Well, I can tell you that if you look at the Bering Sea
Jesus
as an
Christ.
example, the predominant phytoplankton community has undergone extreme alteration. It used to be diatoms were the predominant phytoplankton community in the
Right?
Berings. Now it's coccolithophorids. Coccoliths, as we call them for short.
What
Uh,
is it?
they prefer warmer waters. So right there is an indication of the water parameters changing, and it's changing to a warmer situation. And the diatoms don't like that too much, so you get a different group of phytoplankton, and that of course changes the rest of the dynamics of the ecosystem. What zooplankton feed on the phytos, etc. So we're already seeing this, and Rebecca Woodgate research is showing how some of that warm water from the Pacific makes its way into the Arctic through the Bering Strait, and that warms up the Arctic Ocean, affects sea ice, affects the halocline, in addition to the warming waters that come in through Fran. So yeah, it's You know, that heat that's in the ocean is going to go somewhere. It's going to spread out throughout the ocean.
Yes, that it is. So they say, repeating and analyzing their nightmarish scenario, breaking the food chain that supports billions of creatures and one of the world's most important fisheries is an eye opener, a shocking statement that lingers and one that should motivate a worldwide movement to halt greenhouse gas emissions, the principal cause behind excessive heat ocean in favor of saving marine life. Hello? Anybody out there? Furthermore, speaking of breaking the food chain, since 2019 until July 29th, 2021, a total of 481 whales have stranded along the beaches of North America, including 69 in California. What the fuck? And we don't even hear this. We don't even hear this because we are so stupid. We are an ignorant bunch of stupid assholes. Unprecedented death of marine life is happening all across the planet. This is not normal. An important study of coral reefs in the Mediterranean Sea shocked scientist Joaquin Garbo, stating, frankly, I have never thought that I would be seeing it, and it's happening really fast. The Garbon study found coral reef communities that had been devastated by heat waves 15 years ago still not recovered because of the short sequence between subsequent heat waves. Another study explains corals need at least 10 years to bounce back, but increased global warming is reducing the ability to adapt. And that's what we were talking about, Jim. I mean, really.
Yeah.
Moreover, we project that 99% of coral reefs will be exposed to 1.5 to intolerable thermal stress and 100% of coral reefs at 2C. There's a lot of references in this. He did his homework. That calculation was in response to the IPCC government IPCC projections that 1.5 C above pre-industrial could hit as early as 2030s. That's right around the corner. Right around the corner. I mean, it is here. Australia's Great Barrier Reef, the largest coral system in the world, has experienced 5 mass bleaching events. 1998, 2002, 2016, 2017, and 2020, all caused by rising ocean temperatures driven by global heating. In the year 2020, water temperatures hit the highest ever recorded since instrumental records were first kept in the year 1900. Wow. In, wait, let me unmute you. Yes, go ahead.
The other issue, of course, in the coral bleaching, because you've increased, the CO2 mixing with the water becomes carbonic acid
This
and
fucker.
creates the bleaching. But another problem with that is we're changing what's called a calcite compensation depth.
Okay.
Basically, the CCD is the depth in the ocean that below the CCD, the pressure and the temperature and the pH is such that calcite stays in solution. Above
Mm-hmm.
the CCD, it can precipitate. Well, organisms that have shells that, based on calcium carbonate, you typically find them living above the CCD.
Yeah.
The region where it shifts over is called a lysocline. But guess what's happened to the CCD?
What's
It's
happened?
getting shallower and shallower, which means that it's getting more and more difficult for the organisms to keep their homes,
Right.
to keep their
They
shell. The
can't
shells are
live.
literally dissolving out from around them.
That's
That increases mortality.
It's really awful. I have to do some homework here. I don't know if I can do it. I'm getting really pissed off at something that's happening in the chat. And if this person that's in the chat would like to talk to me, they're going to talk to me off the chat. And they know that they can get in touch with me. It's rude and ignorant, and it's really pissing me off. And I don't know how to stop it. Please stop it. Jesus Christ. I'm sorry, Jim, but this is a problem. It's a problem, and I would really like it to stop. Whatever. All right, guys. I'm going to continue this before I get so annoyed. Um, all right. So we talked about the reefs. Okay. And then, all right, let me get back into this here. That was only 2 years ago. All right, demonstrating the narrowing time sequence between bleaching events. Additionally, a recent 2022 unpublished study written by experts at the U.S. National Oceanic and Atmospheric Administration's Coral Reef Watch Unit states the Great Barrier Reef was in the grips of a record breaking heat spell yet again in November and December 2021. That beautiful Great Barrier Reef, which is one of the great iconic ecosystems of the planet, easily spotted from the International Space Station, has a history of resilience. But how much more can it take? I'm going to go through this. I'm going to go down because it's getting long. Um, let's go down to. All right, let's go down. We're going to. Blah, blah, blah. Meanwhile, more than 1 billion marine creatures killed by a heat wave off British Columbia less than 1 year ago serves as one gigantic wake up call. But if 1 billion deaths does not slap, and I wish, you know what, I have the kick the can because this is what we do. We kick the fucking can. One big slap in the face. It's not. And wake up global governing bodies, then what does it take? 2 or 3 billion? Or how many more? How many more? Although at the rate things are going, the world will be running out of marine life soon enough that it may not really matter. Assuming no major yes, radical changes in socioeconomics, neoliberalism, accompanied by all powerful eco related policies by the leading nation states of the world. Some scientists believe the oceans, limping along, only have another 3 decades. Sayonara! Sayonara, he says.
As I said, the oceans are dying.
I'm glad we
Uh,
read it. I'm,
no,
I'm annoyed. I'm glad we
that
read it.
that 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 basically, backs up my assertion that the oceans are dying. It's right there, and people don't realize, as the oceans go, so do humans. As we kill the oceans off, we're killing ourselves off.
Yeah, it's very, very scary. But on the other, okay, I'm going to say it. Torstein Vidal, you need to leave the chat. And I don't know how to get rid of you, but please leave the chat. We will take this off a line. He's in Facebook spamming the chat. And I named him. Okay? Stop it. Grow up. Jesus Christ. This is what I'm talking about. I'm tired. I don't need this shit. How do you do this? How do you stop someone, make someone grow up? Jesus Christ. Just wreck the show. Everybody knows who you are. Stop it. All right, guys. Thank you. Jim, people are going to keep snorkeling. Researchers are going to keep researching. They're up
Yep.
there in that I'm going to follow sea ice, the sea ice adventures. Um, I'm excited, and
Well, I
although
was
Robert
on.
Hunziger, what? Although Robert Hunziker really
I
packs
mean,
a
I know that a
punch.
lot.
Do we have a lag?
I have major lag. I was going
Okay.
to say that I've been focusing a lot on sea ice. I spent years doing that, but it's because, to me, what's happening in the Arctic definitely does not stay in the Arctic, and
No.
Arctic
No.
amplification really. is you know is a harbinger of what will happen to the rest of the planet. And as the Arctic warms, oh good gosh, the rest of the planet's going to warm. You know, and well,
Yep.
we probably don't have time to get to the water vapor article, but a quick synopsis is that
What the
water
hell?
vapor.
Everybody else does major long shows. Have you ever seen the newest thing on YouTube is to do 3 and 4 hour shows? These guys are doing it, but you know why they're doing it? Because they do super chats and they make a friggin' boat fucking load of money. Oh my god. They could buy a computer, a new computer, and like from one show. But they do political stuff.
Yeah,
I've been perusing the other YouTubers to see what they do. It's interesting. But all right, you mean the which one? The
let's see.
NASA one, steamy relationships, the atmospheric
Uh,
water vapor one.
yeah, that one.
That was pretty good. Oh wait, you know what? We have a question before we go. I forgot this question. How long till the
Sure.
Laptep C gives up its methane? Uh oh. I wonder if we're just going,
Well,
no.
that's
Oh,
difficult to say, but there, but it's not just the laptop; it's the Kara, it's the East Siberian, it's the whole shelf system that rends the Arctic Ocean basin. There's shitloads of this is a scientific term. There's shitloads of methane there, waiting to
you could say shit. You
waiting
did
to.
this shit. Everybody's with us.
But I mean,
Oh,
they're as Natalia has estimated, there are some large amounts of gigatons of methane just in the shelf system alone that could be released as the warmer temperatures start thawing out the permafrost. And that's the biogenic source of methane. When you get to the shelf break in the lab test, where it goes from where the bathymetry declines very quickly, there's new studies showing that the warming waters is melting some of the ice caps that you know plugging up like huge caverns,
wow.
and this is releasing, instead of being a slow release of methane that you usually get from a biogenic source, these are explosive releases of large amounts of methane. That's called a thermogenic source. And there's some concerns about how much methane is going to be released there. Couple that with the methane on the terrestrial side of the permafrost. And yeah, there's just a huge quantity that is being released, and the question is, does it get released slowly or in large bursts? Farting or burping events, basically, and that either way, the implications are extremely dire and serious.
Dire and serious. I've got the article pulled up. We don't have to read the whole thing, but if you want to give us the synopsis of the water vapor here, look at that.
Try
It's
to
a
give a
beautiful
bit of
picture.
a little synopsis here.
If we
So
don't lose you.
basically, they talk about it. They talk about that water vapor is Earth's most abundant greenhouse gas. It's responsible for a lot of the greenhouse effect, etc., etc. And water, of course, is part of the water cycle. No surprises there. But
Hmm.
you know, water vapor is an extremely difficult parameter uh, to model, to include in climate models, because it can both be a heat trapper, it could also be a heat remover. For example, if you have clouds, the top of clouds, you have albedo. So it reflects the sun energy back into space, but on the underside of the basically the same cloud, it could be trapping heat, that radiates off the ground. So it's an extremely difficult parameter to model, and that's why you often see, when these projections of how much warming is going to occur, you see a wide range of such projection. It's because of how the different models are treating the water vapor parameter. So
Wow.
it's extremely tricky to um, to get a good handle on. And what they're basically stating here in the article, there's some nice little pictures there showing a water cycle and so on, is that water vapor works in conjunction with CO2, and when they work in conjunction, the warming effect is exacerbated. It's increased. They work
Okay.
synergistically. Most people think it's just CO2. No,
Mm-hmm.
it's CO2 and how it works with water vapor. In other words, it's not just temperature alone, but humidity. And think about it. You're burning fossil fuels. Take gasoline as an example. That's
Mm-hmm.
basically alkane, what you're putting in your vehicle.
Yeah.
Alkanes are hydrocarbons. It's just carbon and hydrogen. And when you combust the hydrocarbon in the presence of oxygen, that's what combustion is. What are the products? It's not just CO2. It's water vapor. So when you're burning fossil fuel, you're putting CO2 and water vapor into the atmosphere. And those two together actually makes the warming effects even worse.
Oh,
And
just such great news.
that's that's kind of the essence of that article there. Um, and
Yeah, it has some nice
think about it.
graphics here. I like
Yeah,
this
it's a
one
very
where it's showing the way the cycle,
like the
going
water
around.
cycle. Yeah,
Yeah.
yeah.
Just so you know,
And
guys, the drama on this channel's over. I deleted the Facebook post that was showing us live over there completely. There is a problem, and it is a bad one. All right, we'll go on. So,
so that
transpiration, condensation, transport, precipitation, snowmelt runoff, surface runoff, infiltration into the groundwater, groundwater flow, and plant. That's cool. You could make a song out of it for children.
yeah,
Uh,
they use stuff like this in like grade
yeah.
school. Yeah,
Yeah, if
I've seen it.
if NASA doesn't become a banned subject in the United States. Remember, this says climate
Well, there's
change.
that.
Remember? Yeah, remember the
Because
people that are trying to do
it
things?
might make some people it might make some people uncomfortable.
Yeah, oh God. God, we should, yeah, lest we talk about this. Greenhouse
Snowflakes.
gases.
This next graphic is really cool.
Yeah.
Let's like look at that
Okay.
one there because it shows kind of the fact that the CO2 and the water vapor do synergistically exacerbate uh, what the situation will be. So the main thing is it's not just CO2; it's the water vapor in addition, and it's that's that's how it is. I mean, you've got water vapor trapping heat, but combined with the CO2, yeah,
Wow.
just makes things
That's nice.
warmer.
They have nice graphics that really do show you what's happening. They do have a good website. A different breed of greenhouse gas. Wow. You want to talk about
Well,
this?
and they're basically saying that it's the water vapor, it's the CO2, but of course it's the methane, and don't forget there's also the N2O, the nitrous oxide, which is also being found to be released
Yeah,
from
this one
the
has a lot.
permafrost.
I
Yeah,
see it.
I mean
Look at these. These are nice graphics. We always love graphics on this channel. Oh,
that's why it's more accurate to talk about CO2 equivalent levels in
yeah.
ppm, not just CO2,
I think you've
because the
always said
equivalent
that.
level accounts for the CH4, the methane, and the N2O as well. And so, yeah,
This
that's a
is
more
pretty
accurate
good.
measure of the. Oh yeah, this is
Look at this is a
there's
pretty
a lot
good
of meat in
teaching
here.
website. Yeah, this is a teaching website. I mean, this is good. I like it. I like it. It shows. I mean, I would refer
Noah
anybody to
Noah
this.
puts out Noah
Yeah,
puts out some good stuff there.
yeah.
It's
This is
accessible for
definitely
folks there
refer.
without getting too wonky. you know,
Right. Yeah, but
I can,
it's well
I
laid
sometimes
out.
get a little wonky on my videos, but oh well,
You're fine.
force of habit.
We have another we you're fine, Jim. You're just fine. We have another question. Um 130% F plus 90% humidity causes hypothermia, right? Is that
Was it
so
hydrothermia?
130% oh,
Oh,
hydrothermia.
hyper
No,
hydrothermia.
hydrothermia. Hydrothermia. That's a new one for me. Hydrothermia. What do we know about
Well,
hydrothermia?
that's kind of like a combination of hyperthermia from overheating combined with humidity aspects.
Wow.
I think is what the term is trying to create there.
Very cool. All right. So I see,
And,
it's yes, global
and a nice
water.
little picture of the
Phew.
flooding.
Yeah. And this was in Texas in 2019. All right, well listen, I like that website. I think it's pretty good. Guys, we've done pretty good
You,
tonight.
you can probably put the link in the show notes there.
Yes,
You know,
I
for these.
did. I think I did already. I think I had that done.
Okay,
Oh my gosh. Well, we have
cool.
66 wonderful people that are with us. And I want to thank everybody. Rich says nitrous oxide is no laughing matter. Oh, do I have? I don't
Right?
even have. I don't think I have that laughing sound effect. Nope. But I was all okay. I had to play something. You know, you have to play with the sound effects. All right. Well, anyway, listen, guys. Jim, it was fun. Even though I got annoyed and we had a troll who used to not be a troll, but who was a troll, and
Just expose a troll to
technical.
sunlight. I'll take care of it.
Well, this person's known by everybody, but I'm done. So it's like a bad relationship, you know. I don't need an online bad relationship. Nope. Sorry. Okay, well, guys, thank you again. And don't forget, tomorrow is State of the Planet at 6 p.m. Eastern. And then after that, we're going to do a Jim, everybody State of the Planet. And I'm going to go in the background and just run the show and let the four of them, Jim and Jennifer and Antonio and Nick, just go. That'll be pretty cool. And everybody, thank you, Old Sage Joe and Poppy. Yeah, we're here. We did a long one. Poppy left and came back. Yeah, we did a long one. I might break it up in pieces. I may not. I don't know. I was thinking about playing with things. So, Jim, give us your little spiel on what's your agenda for everything that you have going on.
Um, I just got more videos coming down the pipe there. I think I've got a two-parter on plastics in the ecosystem coming
Cool.
up. There's some other videos I still got to edit and record. More, peer going over through peer-reviewed papers, some details of what's
All
going on
right.
as the heat proceeds on the Eurasian side of the Arctic Ocean, the warming of the Kara
Oh,
and Laptev seas and so on. Some stunning data, I think, stunning data,
yeah.
showing the progression as we proceed to an ice-free Arctic Ocean. So
All right.
it's and and of course in my
Continuing.
heat content update video, I identify the warming of the Mediterranean Sea, and that's the source water for the North Atlantic Intermediate water. That's the water that goes into the Arctic Ocean. That's the water that prevents the ice from forming, melts the ice that's there because of the heating in the Mediterranean. So
Wow, that's a whole other
what,
show. I'll put the links
that's
to your channel up for sure.
lots of crazy stuff going on there. So I'm been trying to hit upon the peer review, but uh,
I love the
after a
oceans.
while,
I really
after a
do.
while, I might just scale it back a wee bit, have shorter videos. We'll see.
Okay, well then now we know.
I've got
All right. So good night, Jim, and thank you so much. And sorry for all the technical bullshit. We are over and out, guys. Mwah! Love you.
Good night, everyone.